My name is Tom Stevens. I'm a Senior Technical Marketing Architect with VMware, and I'm joined today by some members from TIAA-CREF. We're going to talk to you about stretch clusters, and specifically some real-world experiences that TIAA-CREF had with stretch clusters and how they overcame some of the challenges. We'll also go through, and as we finish the stretch cluster discussion, we'll also talk about some of the things that may have made their life a lot easier, or your life if you're going to implement a stretch cluster. So a little bit of a roadmap about what could possibly be coming in the future. We plan on having this a quasi-interactive session. We're hoping that we can get a lot of audience participation in asking questions. Feel free. These guys have a wealth of knowledge. Me, not so much. But again, feel free to go ahead and ask some questions. All right, so with that, let's go ahead and begin. So we took a survey back in 2010 of a segment of our population, our consumers who use vSphere HA, or just vSphere in general. We asked, why do you guys use it, right? And over almost 50% of the people responded and said that they use it for some sort of HA or DR business continuity type reasons. So again, we find that it's extremely popular. Typically, we see that about 80% of the customers that actually use vSphere have enabled an HA type function or are utilizing something like SRM or some other business continuity. Well, VMware, again, has a lot of different products in this space. So, for local availability, we have most commonly vSphere HA. We also have the ability to do backups. And then, of course, for DR, we have SRM. What you don't see in this is really stretch clusters, right? Stretch clusters are kind of in a weird spot. Depending on the customer and the customer's architecture and the customer's needs, they can consider this to be if you will, a DR solution, or they can consider it to be a more availability solution. It just kind of depends on that particular customer. So in this presentation, again, it depends on the actual implementation of it, but we're looking at it more from the standpoint that it's not really a DR solution. It's not something that, say, replaces SRM. It's more of an availability or disaster avoidance solution, and we'll get into that here in a bit. So, for those of you guys who don't know, a stretch cluster is typically defined by having two sites that are separated by a distance, typically of about 100 kilometers in length, right, or less. It's basically the same thing as you're used to with vSphere HA. All it is really the hosts that are comprised of the cluster are located in two different locations, right? And again, those locations are physically separated. Now, this poses some interesting things because in addition to obviously having a network between these two sites, you're going to need to have storage connectivity and an active-active type configuration where both sides can access the information on the data store as needed, right? As of right now, VMware only actually supports 3 separate storage arrays for this. So it's just something to keep in mind. Now, I guess one of the big questions is, why do people do this, right? Again, there's different thought processes as far as how this is designed. One of them is just to provide HA. Particularly, some people want to have a way to control or a way to recover from, say, an outage of a building. So, for example, if Godzilla came in and stepped on one of their buildings, all their VMs would automatically fail over to another building. In some cases, like for example in universities or whatnot, this can be highly advantageous given their actual environment. We also see stretch clusters highly used in Europe. In Europe, the actual size or the distance between data centers typically can be a lot smaller than it is, say, in the US. And so we see a lot of times European customers tend to use stretch clusters as a way to provide not only availability, but they look at it again as a form of DR that goes in between different cities. People also use it for balancing the workload. So for example, what they'll do is they can enable vMotion between the two sites if they have a stretched layer 2 network, and they can also just move the VMs from building to building. So they can, again, balance the workload and they don't have all their eggs in one basket, right? Additionally, some people use it so that they can so they can go through and survive, if you will, a certain type of maintenance actions that they might have. So for example, let's say you have a building, that building needs to have some work done on its power, right? So the power is going to go down for the building. You could easily move all the VMs to another location and you're still up and running. You will not be affected by that type of maintenance action. And lastly, it's pretty easy to go ahead and maintain access or availability for the applications. Again, this is just vSphere HA, it's just stretched over a longer distance, right? Now, when we talk about stretch clusters, we have a lot of people out there who may not necessarily have the same definition of what a stretch cluster is as I do. And there's a lot of misconceptions about what it can do and what it can't do. First of all, it's not really disaster recovery, right? So if you look at SRM, you'll notice that SRM has the ability to do like a DR plan. You can go ahead and test things, so on and so forth. This doesn't. Again, it's just vSphere HA. It's just going to move. It's also not, if you will, controlled. So, for example, in SRM, you have the ability to say, I am declaring an emergency. I want to go ahead and bring up my DR site. This is all automatic. It's not going to stop doing something just because you haven't given it the okay. If something fails, it's going to try to start it up. You're also clustering the sites, right? Not necessarily the actual components. So again, what you're trying to do is you're trying to make it so that if a site goes down, then you'll be able to actually bring it up on the other side. Now again, you have some sort of network between, say, site A and site B. The problem with this is, what if you have someone who has a backhoe, digs up that network connection between those two buildings, right? Then you're in trouble because you can't really determine in a deterministic manner if that site has actually just lost its network connection or if it's actually down. So what you'll end up needing is a third site that will actually act as what we call a witness site. And typically this is really common for, say, your storage solution, where you want to make sure that the storage is only available on the site that is actually needing the access to the data. So this third site, again, it just adds a little bit more complexity, and what it does is it has connectivity to both sites. And that way, supposedly, you should be able to identify whether or not you are having just a network outage that's decreasing your ability to talk between the site A and site B, or whether or not you have a total site failure. Some people also think of this as if you will, a poor man's DR. And again, I'm not going to get into the whole discussion about whether or not it's can be used for a DR solution or whether it's just HA. I think that's kind of analogous to whether you like Windows or whether you like Macs. Again, it's really on how you design this. But again, I'd like to point out that it's not necessarily always the cheaper solution. Yes, you're not necessarily paying the cost for SRM, but you're also not getting the features and functionality of, say, SRM. Additionally, like I mentioned, we only support 3 different arrays. So if you're not using one of those arrays, you're going to have to buy the storage, you're going to have to configure it, and again, there's additional management capabilities that you're going to have to worry about, especially with the network layer and as well as the storage. So what I'd like to do is I'd like to pass this over to Charlie of TIAA-CREF, and he's going to lead off with a discussion about how they actually went and designed a stretch cluster environment and talk about some of the problems and the solutions that they ran into. Charlie?
Thanks, Tom. So I guess it was about a year ago we started this project. Let me skip slides here. So our business partners came to us a year ago and said, hey, you know, our applications are not highly available or not as highly available as we'd like. And what can you guys do to help us with that? So one of the challenges we had was around infrastructure. I think when people think of high availability, they look at infrastructure as probably one of the most common areas to focus for uptime, if you will. So our goal was really to set out and say, how can we take legacy applications that don't necessarily have capability to be HA within the application or load balance in front of the application and make them highly available. So we focus primarily on the infrastructure for this. So some of our assumptions are listed on the slide here. Shred cluster was, at that time, this is about 14 months ago, something that wasn't really prevalent. There weren't a lot of discussions about it, and we didn't know what it meant. But as we walk through today with you, we'll go through the various components of the network, the storage, and the compute, and how we laid that out. So, we didn't do this alone. So we worked very closely with some of our partners, Cisco, NetApp, and VMware. And we also referenced several best practice documents that are publicly available, some that recently came out, such as the DCI document listed here. We've met with VMware several times, worked with Tom and his team, as well as VMware product management, to address some of the issues that can come up when you do things like stretch clusters. And we'll get into some of that as well. Our approach was taken from several different levels. I'll say first and foremost, we wanted to provide component level survivability. I think when people say component level, we often think of NIC cards or HBAs, things like that. But in this case, we really wanted to break it apart as storage, network, and compute. So any level could survive on its own given a failure scenario. We didn't want this to be an environment that when something failed, you had to fail the entire site over. So that's one of the reasons we took that approach. Moving into that a little more, when you think about the different scenarios of a storage failure or a network failure, or as Tom mentioned, a split brain scenario, these areas are, as you'll see, some of the ones we're still working on. This is definitely not complete, and as I'd like to mention, please ask questions if you have them throughout. My colleagues Andy and Glenn have some other details to go through. We really want feedback, so questions are more than welcome. And for us, this is something we're still working on. It is a proof of concept for us, and we're looking for lots of feedback from you guys. So with that, I'll turn it over to Andy Daniel, who is an engineer on our team as well. So thanks.
Oh, there it was for a second. No. Oh, there we go. All right. Yes. All right. Technical difficulties overcome. So the first thing I really want to talk about here is network. You'll see as we go through this, we actually kind of divided it up: network, storage, and then compute for each section. And like Charlie said, we definitely ask that as we go through it, if there are any questions that you have, definitely raise your hand. We'll see if we can get you to the mic and we can try to answer them. We want to try not to kind of rat hole and go down and really get too technical. If we do go that, we'll probably ask that maybe just come find us afterwards, that kind of thing. We'll be glad to talk about it because there are lots of very technical things that we can talk about and things that we found. So as we go through it, we'll try to explain as many of them as possible without getting too deep and kind of go through it. So we'll start with networking here, and you can see we had quite a few requirements up front, and they're all requirements that you would normally have, I think, even without Stretch. And we want to make sure that they're included in Stretch as well, and then Stretch obviously adds some more complexity as well. So the first thing that we get into whenever we stretch and we go between sites is we need that layer 2 connectivity, right? So that, first and foremost, without that, we have nothing, right? So if we can't move a VM from site to site and maintain connectivity to it, or even the storage back and forth, then we have nothing, right? So that's first and foremost, okay? So the next thing, as Charlie mentioned before, is we need component level failure isolation as well, right? And then as we go through as well, we're moving VMs between, we need high-speed connectivity, right? So it may be one thing in a DR situation, maybe where we're okay if we fail over to the other site, maybe we have less speed at that site, that kind of thing, but that's not what we're looking for in this case, right? We should be able to move our workloads between site and maintain that same level. The end user should never really be able to tell that we moved that. That requires high-speed connectivity between it. So as we go through, you can actually see some of the solutions. In our case, we actually used a DWDM fiber solution to get that high-speed connectivity between the sites. So, and then we also need, just like we would on a regular network, granular quality of service control, right? So as we start to combine and we have DWDM and we're moving storage back and forth, in our case, NFS-based storage, that kind of thing, then we need a way to actually prioritize that traffic and that kind of thing. So to do that, we actually use the Cisco Nexus stack all the way up. So if we start at the compute level, we look at the Nexus 1K all the way up through 2K, 5K, 7K. And those products gave us most of the solutions that we needed to get this done. Some of the actual solutions within the products, as we listed here, are OTV, right? That's getting our layer 2 connectivity between the sites, right? As we go there, then we talk about VPC that's available. I'm not sure if everybody's familiar with VPC, virtual port channels, but essentially what it means is that we, from all the way down to a host level, even the 5K, right, we're able to actually provide uplinks from 2 separate switches to the host. It looks like one switch. And that kind of thing, so we can survive any switch failure in between. So that actually goes all the way up the stack from the 5K to the 7K on up. So it's a great product for that. We also utilize VDC context, right? So within the 7K, as we need to, it's essentially, for those who aren't familiar, lack of a better term, virtualization for switching, right? So we can take the 7K and we can divide that up into separate actual switches, maybe for different tiers or different security levels, that kind of thing, right? So great solution for that. Avoid having to buy multiple 7K solutions, that kind of thing. So. And then last but not least, NXOS, right? So that's the one commonality between the entire networking stack is that we have NXOS across it. And again, quality of service provided natively in there. So starting at the 1K level, we actually tag. So, if we divide up and we think about VM kernel ports for storage, for example, in our case, or different maybe backup networks as opposed to other VM networks, we can actually tag those with a different class of service, and then we can honor those upstream, so all the way through the stack. So if we tag it at the 1K, then the 5K can honor that, and we can divide up with FWQ there, meaning fair weighted queuing. It's the solution there. So any questions about the network stack for me? Yeah? Yeah, absolutely. So the question for those, how do we use virtual device context, right? And I think we use it the way most people use it in that case, and really was multiple security tiers, right, in our case. So we were able to actually divide up and provide isolation there with VDCs. So, yeah. So, and that's a good question. I don't know that we really touched on this. So the design, definitely as we started, I guess probably the best way to look at this would be almost proof of concept initially, right? And so as we go through the stages and we work through some of these things and some of the challenges, particularly around OTV in particular, we're at the level now where we have not actually put this into production. You'll see that as we summarize towards the end, there are definitely some issues that we still have with it that have kept us from being able to do that today. So yeah, I think I would consider this, I wouldn't really call it a lab because we're really running on what I would call sort of semi-production gear as we move towards it. It's not necessarily a playground like a lab normally would be. We've tried to make it very production functional in terms of change control and that kind of thing. So, yep.
What's your latency between the sites? Are you doing any of this on ESXi?
Okay, so we'll get to some of the other particulars in regards to versions. The question was, are you? I think first was latency. I'm not exactly sure. Glenn, do you remember what's our round trip?
It's about 25 milliseconds.
Yeah, about 25 milliseconds in this case, right?
Sorry, about 0.25 milliseconds.
What is that?
0.25. The decimal makes a difference.
Oh, sorry, 0.25. Okay, good point. Yeah, that would actually be pretty. That would be pretty big, wouldn't it? Yeah. And this is actually 4.1 in this case. So, and we're going to talk about how 5 resolves some of our compute issues when we get to compute.
Did you guys set a minimum of what that latency has to be, the round trip has to be before you start seeing degradation?
VMware did.
Yeah, exactly. So that's, I don't know if you've seen that, and I don't know if we even talk about that, but that is one of the things that VMware has said, if people aren't familiar. I think 4.1 in reference to vMotion, that kind of thing, is somewhere in the neighborhood of 5 milliseconds, right? And then that actually gets doubled in 5.0 that we'll see. So I think, unless there are any other questions, I don't want to extend this out too much. If anybody have anything else specific to network that's really pressing? Yeah, okay. One last one. Exactly. I think we definitely did an evaluation. The question is, why did we really choose DWDM in this case? And yeah, it was very specific to our case, right, geography-wise and cost analysis, that kind of thing. So, yep. Okay. Well, with that said, I'm going to let actually Glenn come up and talk a little bit about the storage aspects solution.
Thanks, Andy. So I'm Glenn Walker. I'm with TIAA-CREF, primarily focused on storage, and over the last few years, how it interacts with virtualization is really the primary focus lately. As they mentioned earlier, Charlie and Andy, we really started this process based on what we thought were some pretty high-level business requirements of improving HA, adding capacity, and trying to be as efficient as possible with collapsing multiple network tiers together. So the first step of that was networking. Unfortunately, without networking, you can't really have anything else. So we built on the idea of OTV and the common IP network between the sites, the ability to essentially move a VM or some other workload from site A to site B without having to re-IP, something you do have to do with most implementations of SRM. We wanted to avoid if all possible. That's where this started. Storage basically builds on that level and provides additional functionality to enable compute. So some of the technical requirements we came up with based on those business requirements. We mentioned before we needed component level and site level failure isolation. What that means to us is any specific part of the stack, whether it be the network, the compute, the storage, needs to be able to survive on its own. So if one fails, we don't want to have to move the entire site workload to the other site. That's a pretty big hammer approach. Businesses usually don't like that too much. Second thing we try to build on is the multi-tier resource sharing. What that means to us is we have multiple network tiers that are providing entire application stacks for web and other things like that. Web servers, middleware, actual data, the component that provide the entire application stack end to end. So if you look at it in a traditional model, this is a pretty expensive proposition. You have dedicated switches for everything, dedicated storage for everything, and it can get quite out of control. In this particular implementation, what we try to do was leverage the multi-tenancy functionality of each one of the stacks, VDC on the Nexus, multi-store on the NetApp, to consolidate as much as possible, and within the security parameters we had to ensure that we still maintain security, there was no leakage from one network to another, and we were able to consolidate and provide the lowest cost approach possible. High performance I/O is every storage guy's dream or nightmare, depending. We needed to make sure that whatever we built was performance capable. The workload is something that's usually unknown as the end state. We knew a bunch of applications were coming. We didn't know how many, how big, and what our growth rate was over time. So we need to make sure what we put in place could scale and could perform. Efficient capacity utilization. Storage is not cheap. It is very expensive. It's one of the most expensive components of the data center. So we need to make sure that we could squeeze as much capacity out as possible with the lowest amount of cost. And then, of course, we leveraged in our previous environment NFS for our VM storage. We liked it. We got a lot of benefit out of that, and we wanted to continue that. So those were our pretty high-level requirements from a technical perspective. In our particular implementation, what we have in our legacy environment, as well as our new environment, is NetApp 6000 series, specifically 6080s. They are large enough to scale to meet our needs. They perform pretty well, but the hardware is a little immaterial to what we were doing. The real features of the platform that we made use of, first and foremost, Metro Cluster. We had to have a way to stretch the sites. That's not something that's easily done with storage or any other component. NetApp has a solution that has been in use for, I guess, 8 or 10 years. As previously mentioned, very common in Europe, not so much in the US. Most people have sites that are pretty wide apart. What that gives us is the ability to have a controller in each site and to mirror all the data. So if controller in site A writes, flushes cache to local disk, it does so to the remote site as well. Basically what this gives us is synchronous replication, so that if something happens, if a controller fails, if a disk fails, you have a guaranteed data consistency in both sites. Basically each site can stand on its own. Second part of that is it still provides a normal HA failover that you have to have even in a non-stretched environment. The controllers work in tandem, the disks work in tandem, parity, all that good stuff. In this case, though, one of the things that we're hoping can be improved upon later is instead of having one controller in each site, you have multiple controllers in each site. That is a risk that, based on our design, we have mitigated. Basically, the assumption is that one of the sites is always functional, so if there is a failover event, you continue to run. That said, we obviously don't want to run with a single controller for an extended period of time, which could be a possibility. Second part of this is multi-store. It gives us the ability to carve up the storage into multiple logical layers. In our case, that means different physical connections in some cases, depending on the network tier. But more importantly, it means we're separating workloads. We're making sure that workload A cannot see the data for workload B, and it's beyond the simple NFS export or VLAN scheme. Back to the capacity thing, deduplication. That's something we've done quite a bit. We've seen some really good results with it, so we continue that here in our production environment, our existing production environment. We've seen about 40% savings, which helps to reduce the storage costs. So you can buy, higher performing storage, but you get the effective cost benefit of actually reducing that, so that it's more like a lower tier. Something that's really not mentioned here, and it kind of goes back to the performance piece, is flash cache. Again, something else we use already. We get higher I/O. In as many cases as possible, we try to take concepts we had already learned from our existing production environment, things that worked really well, and extrapolate those. So the two pieces at the top are really the new ones for us. With the exception of Tiebreaker, everything below multi-store is something we've done for the last 3 years. The top two pieces, Metro Cluster and Multi-Store, really go back to partner involvement. There are published white papers from Cisco, VMware, NetApp to talk about secure multi-tenancy and to talk about stretched. Unfortunately, they're not the same white papers, so we really took kind of the best of both design concepts and put them together for our environment. Again, NFS is something we have used quite a bit. It's really low management, lightweight, very fast, efficient. But really the most important part of our overall solution, besides Metro Cluster Multi-Store, is Tiebreaker. So one of the things Tom mentioned earlier was split brain. Unfortunately, split brain is a bit of a challenge. You are truly clustering data centers at this point, not simple components. So in a traditional cluster model, you'll have an A node, a B node, and a tiebreaker, a quorum, in most cases, a quorum disk. That's not really easily possible when you only have two of something, right? There's no third. So in our case, we leverage our DR site. And in the case of our proof of concept specifically, we have a logical site A, a logical site B, and something completely removed from that that is really a third logical site, different subnets, different gear, different networks, the whole 9 yards. That is where this tiebreaker component sits. And it's very simple in concept. To prevent against split brain, to prevent data corruption, the Metro Cluster solution does not provide a failover mechanism if both sites lose sight of each other. If a controller fails, it'll fail over. If a disk fails, it'll fail over. But if everything is lost at the same time, there's no real way to tell with the built-in solution if the entire site is really truly gone and you need to invoke disaster, or if it's in a temporary condition where the connectivity is just lacking. As you can imagine, if you propose a solution that costs millions of dollars to improve HA and there's no automatic failover, that's going to get some raised eyebrows. So Tiebreaker kind of mitigates that for us. What it does essentially in the DR site, a third site with independent connectivity to the other two, is it watches. It watches every few seconds to determine if there's an actual event. In normal case, if the tiebreaker can see both site A and site B, there's no activity, right? If it loses sight of one of those other primary sites, site A cannot be seen or site B cannot be seen, it actually checks to see if they can see each other. If they can, again, nothing takes place. The only time there's ever an activity invoked is if the tiebreaker can only see one of the sites and he can also not see the other site. Basically, that's as close to true isolation as you can get from an automated perspective. It technically invokes split brain for you. It causes a failover of one of the sites to the other, but it does it in a very controlled way so that you're dealing with an edge case. Basically, you have almost guaranteed that one of the sites is truly isolated. What this does for us is it allows us to have an automatic failover without running the risk of the third site actually having a production workload that's still functional. It has independent connectivity back in as well as the WAN side to essentially all but guarantee that that site, whether the VMs are still running or not, are not talking to the world. So running through all that, basically we've used this to provide as much secure multi-tenancy, as much stretch protection as we can, and as much automatic failover as we can. Are there any questions?
How big are the clusters?
What do you mean?
How many ESX hosts?
So the question is, how big are the ESX hosts? How big are the clusters? It varies based on the network tier we're talking about. In some cases, it's 3 in each site. In some cases, it's 6 in each site, but we have multiple clusters.
The capacity, are you building it so if you completely lose a site, the whole load goes to the other, or is it just one and board a couple?
Yes, so the question is the capacity built so that if one site is lost, the other site can remain running? And honestly, we'll talk about some more of that in the compute section, which is next up. But the long and short of it is it's built so that we have maintained 50% reserve, so one site can stand on its own. I think there's a question over here. So the question is Tiebreaker a third-party product or is it a NetApp product? It's a NetApp product. I believe it came out of their PS organization. Quite frankly, it is not fancy. We would like to see it improved. We would like to see it productized, and some feedback we've already given. It is an official NetApp sellable product. It's just a really nice Perl script. There's a question here.
Yeah, you said you had some clusters that were 6 hosts a site. How are you dealing with the limitation of 4.1 of the limited number of primaries, no official support mechanism to split that up?
Yeah, we'll talk about the primary, secondary challenges in the compute section. We'll cover that. Question?
How much storage are you handling with this cluster?
So the question is how much storage is in the cluster. Specific to the 6080, there's about 30 terabytes of usable storage per site. Unfortunately, when you're mirroring, that becomes a very expensive proposition. So in reality, we have about 60 plus terabytes raw dedicated to each site. Basically, there's an A copy and a B copy for everything you do for each one of the nodes. So that is way more expensive than we typically see. We do not mirror in our legacy environment. So we're really leveraging deduplication to try to mitigate that as much as possible. Question? So the question is, do we do anything asynchronous? We actually do a lot of asynchronous. We have hundreds of terabytes today in our legacy environment that is asynchronously replicated. Our DR site is a significant distance away, and there's quite frankly just no way to get it there without asynchronous replication. That is something that's well known to us already, so we do that all day in, all day out. This was specifically a proof of concept to marry the different technology stacks together and provide stretch, which is synchronous by definition. Question? So the question is, what is the distance between the two sites and the bandwidth that we're providing? So as the crow flies, it's about 12 miles, but as the network links travel, It's right around 25 kilometers is probably a better way of measuring it. One of the things mentioned before was the magic number of 100 kilometers. 100 kilometers is what most storage vendors will tell you is the magic number. It's roughly 1 millisecond round time. Most storage vendors don't like to add extra latency to the workload. And I think one of the questions earlier was, what is the impact at which we saw performance degradation? Given that we had a site that was so close, we measured based on what we would see day in, day out, the 0.25 milliseconds. We have no intention of going up to 100 kilometers, so we didn't bother measuring there. That said, we saw negligible performance impact. Most running workloads saw no difference. We know that there are edge cases with our current environment, essentially poorly written applications that do very small transactions in a very sequential manner, really batch-driven processes. These will more than likely feel some latency degradation, but those are really not something that we're looking at targeting for this stretched environment. Question? Sync mirror with fiber channel in the back end, yes. Last question, we got to go to the next stack. The deduplication is built into the NetApp array. It's a batch process that runs based on a schedule. All right, any other questions? See us towards the end of the presentation here, and we'll talk as much as you want to hear. The next part of the stack is really the compute layer. Network and storage enable compute, and the compute is where the virtualization magic happens. So, Andy, if you want to come up and talk about compute.
Can you hear me? Are we good? All right, good. Not the complications. Yeah, so we've gone, I don't know how long now into the presentation. We haven't really talked about VMware, right, vSphere. So finally we get there and we can talk about it. So we talk about network and we talked about storage and they provide the foundation, but now we really talk about VMware and what we use. And the question came up very early on, which version were we using? Well, when we started this, ever how many months ago, we actually started in 4.1, and what you're going to see is that absolutely provides some challenges, one of which came up in the question, well, what do you do with HA primaries, all those kind of things. The good news is that a lot of this is solved in 5, and hopefully we'll have enough time where Tom can come back and talk about it a little bit. But if we look back at our core requirements, right, they're really exactly the same that we had with network and storage, right? So we want, component, site level failure, isolation, right? At the end of the day, when it comes down to it, we really need that workload mobility, right? So we provide the networking and storage, again, be able to move the workloads around between sites. That's the key, right? Obviously, the solution, as we said, is ESX 4.1 in this case, right? HA and DRS, right? That's what we talk about, stretching the cluster, right? So that's the cluster itself. That's how we get HA, DRS, right? Now, underneath that, though, we have Virtual Center. We have the other pieces. So, and I'm surprised, frankly, that question hasn't come up. But how do we get Virtual Center in both sites? In our case, we actually used vCenter Heartbeat, physical nodes, and we were able to actually fail over between the two. Networking-wise, we used, like we said before, the Nexus 1000V VDS. Obviously, vMotion, the primary tenant for all this, right, to be able to vMotion between the actual sites. Right? Now, at the very bottom, we talk a little bit about vCenter Orchestrator, and really, we developed a custom sort of health check plugin to really be able to see. We talk about latency between the sites. So what happens if we have storage in one site and we vMotion the VM to the other site, right? And the storage is on the other side. Well, obviously, then our actual storage traffic is traveling the DWDM across the loop, and it's slower in that case. And that's really where we leverage this custom plugin to be able to tell us, run through the site, find a virtual machine that has its storage in A but is running out of B, right? And in that case, tell us about it, and we'll go ahead and move either storage vMotion its storage onto a volume that's in B, or move the VM compute back to A, right? So again, that's something that's a little bit custom, not out of the box. We had to actually write that workflow to help us do those things. So this sort of combines all the components we've talked about in a logical diagram to really see how it all works. You'll see what we call the pod representation in this, and that's really our compute cluster, right? What we drop in. In this case, we're talking about HP blade chassis and hosts. From there, we travel up the stack networking to 5K, 7K, and then down to the storage. And then on the back end, as Glenn talked about, Metro Cluster, utilizing Fiber Channel on the back end to actually share the storage. Real quick, any questions about actual topology before? Okay, good. So, challenges. I kind of chuckle a little bit when we talk about the challenges because this is probably the most packed slide we have that you've seen so far, and that's to really say this is definitely something that's doable, but there are a lot of challenges out there, and we're going to talk about time permitting here, hopefully, about how VMware really helps us overcome some of those challenges. But first and foremost, what we really found is that we had cultural challenges, quite frankly, right? I mean, this is something that's very new. Management maybe doesn't necessarily understand how it works at a certain level, right? How do we get beyond that? And that's something that we really had to work through. So, and then resource challenges, right? Obviously, we have 2 sites, increased implementation time, more difficult to implement than single site, right? Operational challenges we talked about a little bit, right? Application HA, where are the components of the application? Maybe if I have a tiered application, is the back-end data in one site, but the front end in another, that kind of thing. So that's definitely a challenge to work through. Emerging technologies, right? All this stuff is pretty new, or at the time was very new. A lot more widely accepted at this point, but definitely when we first got started with a lot of this, very, very new. Definitely emerging in that respect. And then all the technical challenges, right? And that's probably what a lot of people are interested in. If I go and I implement this, what are some of those technical challenges that I'm going to run into? And we'll, if we have time, we'll take some questions, but definitely if anybody wants to kind of deep dive into any of the technical pieces, maybe you've started to work on some of this and you've seen some of the things we did, we'll definitely talk with you a little bit more about it. But all the things that we saw up front, with network, that layer 2 extension, how maybe I can extend the network across the other site, but at the end of the day, I need to be able to consume that application, right? How do I come in the front door, and if I have firewalls, how do I make sure I go back out the same door I came in, right? It's stateful, that kind of thing. These are all challenges that we have to work through in that case, right? Storage, obviously complexity there. Compute, cluster constraints, and I think there was a question about that, and I don't want to go too far into it. We can talk about it offline, but I think if you've looked at this and know HA at all, there's definitely a constraint in regards to HA primaries, the number of primaries, and how do we ensure that they're both in the same site? And quite frankly, that's not so it's not a supported way to do that today, right? And so those are some of the things that we'll be able to do in 5 that make it a lot easier. And then mobility of the infrastructure. I talked a little bit about Virtual Center, right? So we use Heartbeat to failover, but in the case of anybody that's familiar with the Nexus 1000V, it works in the same way, right? So I've got a VSM that I need to fail over between sites and that kind of thing. And then even underneath Virtual Center, not to skip that, but it's database itself, right? So we had to cluster the SQL database to be able to move that between sites as well. So, and then I think Glenn really talked about at length sort of the split brain mitigation, right? So we have that through all levels. If we separate the sites, how do we mitigate split brain in that case? For sake of time, I'd rather hold any questions in reference to some of the challenges, and we'll talk about it. Maybe we can get with you afterwards. So this is really a summary of some of those challenges and how we solved some of them. Now what you'll see is that, frankly, quite a few of them are still unresolved, at least in production code today. As we work through. I'll touch briefly. One of the things in reference to network we definitely ran into with OTV is really MAC learning and some of that convergence time. That luckily was fixed in a code release that really helped that out. From there, I touched on this a little bit earlier, but deterministic routing. Which door I come in and making sure I go back out that same door. How do we do those things? Hopefully, things like Lisp. Stuff like that will help those in the future, right? We actually, in our implementation, are working through some of that, but we can't really talk to some of those details today. The 1000V, talked about the VSM availability, right? Today, there's no real solution to that. There's some published documentation on how to do that, but it's really keeping both nodes in a pair in one site. So it means having to get them to the other site if we have a failure. Glenn talked a little bit about tiebreaker in regards to split brain storage. But you can see there's still some other storage challenges to work through. And then it's the compute, right? We talked about it already, how do we ensure that we have at least one primary in each site? Split brain. Now, in our case, because we're using NFS storage, it's not elegant, but we did have a way to sort of prevent split brain in regards to that, and that's the fact that, well, if the storage is not available on one side, then guess what? We can't boot the VMs, right? So that eliminates that for us in this case. It's not elegant, but it works. And then the other things that, as of right now, are unresolved, and that's site awareness in general, right? It'd be great if Virtual Center and all the other components were aware that we were actually splitting them across. And then there's little kind of gotchas that we ran into in regards to DRS rule sets that we're looking at. And that really, for a quick explanation of that, is essentially if we have one VM that's in multiple DRS rule sets. Maybe we use host affinity rules or groups to actually make sure that two nodes of an application, one's on one site, one's on the other. Well, what if we also want to, in one site, make sure that two of those nodes never end up on the same host in one site? Well, unfortunately, DRS has some problems with that, and really understanding which one of those rules takes precedence. So with that, I'll let Tom jump back up and talk about some of the things that are hopefully solved in 5.0 for us, and then we'll definitely stick around if you have time, and we'll try to answer any specific questions afterwards. So.
Thank you. All right, so as you mentioned, obviously there's some problems, especially with the 4.1 release in doing some of these things. From a VMware perspective, we can't solve the world's problems. In other words, I can't necessarily solve the storage problems or maybe some of the networking problems that he has. But we have been working to try to make things easier, especially for stretch clusters. So first of all, I just want to hit on some of the new features that are present within the vSphere 5.0 release that is just released that you may not be aware of in the event that you are trying to configure some sort of stretch clusters. First of all, everybody talks about this primary-secondary thing, especially if you're using blade chassis or stretch clusters. This is pretty important, right? In 5.0, it's gone. There is no primary-secondary concept. It went to a master-slave concept. It's gone. Okay. With that, we've also changed some of the other things. Like, for example, we no longer have a dependency on DNS resolution, right? So what that means is we're not dependent upon any type of external entity for HA within a cluster. Okay. One of the big things, really big things actually, especially when you apply it to a stretch cluster environment, is the use of a heartbeat data store. What a heartbeat data store allows us to do is use the actual storage subsystem as a means of communication between the nodes, so we can determine whether or not a node is up and functional and what VMs are currently running on that particular host, right? Why this is important, especially in a stretch cluster environment, like we mentioned, you could have a disconnection of the network between the two sites, right? But with this ability to use the storage subsystem, we can actually still have a redundant link to be able to determine what the status is of that other site and the host on that site. Okay. We've also added in a couple of other features that maybe not necessarily directly associated with stretch clusters, but for example, we have added in IPv6 support, and we have increased and cleaned up a lot of the logging messages, these type of things. Again, depending on your level of expertise or frustration, you may be looking at some of the log files, so it just helps in readability and whatnot. All right, so in the time that we have left, what I'd like to do is just go in and talk to you about what may be coming in the future. This is kind of a roadmap, so I'd like to refer you to slide 2, I think, the one that we just kind of blew by, saying that I'm making no guarantees whatsoever that this may or may not happen. All right, so with that, first of all, component protection. I know most of you guys who are familiar with HA know that we don't actually monitor the HBA or the NIC, actual physical card within the box. So what we're thinking about doing is actually adding in that capability, not only adding in the capability to say monitor an HBA, but adding the capability so that we can mark a particular host as being in a degraded mode, for example, right? What this would allow you to do is, from a DRS perspective or from an HA perspective, we'll try not to necessarily bring on VMs or start VMs on a particular host that may be close to failing, right? Some sort of preference there. We're also thinking, if I can advance my slide, we're also trying to increase application availability. So with application availability, obviously we need to monitor the actual application. For those of you guys who don't know, within the 5.0 release, we've made publicly available an API that's going to allow you to go ahead and run a monitor script from within the guest OS and actually heartbeat with vSphere HA. So for example, if you want, you could write a simple Perl script, monitor your application, heartbeat with vSphere HA. If vSphere HA detects that there's a loss of these heartbeats, it will go ahead and restart the VM, right? So that's publicly available. It was previously released to just a select partners. For example, Neverfail has a VApp HA product, and Symantec has an application HA product. Either one of these two products both use that API set, but now again, anybody can use it. So we're also planning on taking this to the next step, potentially looking at an application's performance and possibly moving it or increasing the resources if so need be. We're also looking at actually trying to provide some functionality for actual stretch clusters. As was mentioned, one of the problems is not having a ability to have a site affinity rules, right? So that's one of the things that we may be looking at doing in the future. Also, we're looking at ways, again, one of the problems was having VC and having VC in one site. Obviously, if that site goes down, you lose your ability to manage because that VC might actually be hosted there. So we're looking at other ways that we can have multiple VCs, so on and so forth. We talked earlier about the latency requirements, and I forget, someone over here, I believe, asked about what the latency requirements were for the links. vMotion obviously dictates this, and I believe that it's 5 milliseconds for the actual latency. Well, we're looking at expanding that, increasing that, and that it will help us to increase the distance that you could actually have a stretch cluster and do vMotions. Okay? And we're also obviously looking at the concept of why do you want to have another site in the first place, right? I mean, having hardware, having an actual data center, just whether it be a stretched or a secondary data center, maybe it's not worth it. Maybe it's just easier to put that ownership and the responsibility onto some third party like a cloud provider where you could actually do a DR or an HA to the cloud. So it's something else that we're looking at. So that's pretty much all we have. We're more than willing to try to answer any questions, so if you have some, please let us know. With that, thank you very much.